Welcome to Module 4 of Platoon's Intro to Coding self-paced program. You've come so far, learning about variables, loops, and more. Now, we're diving into data structures, which are tools that let you organize and manage your data efficiently. In this video, we're going to focus on two core data structures in Python, lists and dictionaries. These are go-to tools for software engineers working on all sorts of real-world projects. Let's get started. Why data structures matter. A data structure is a way of storing and organizing information so that it can be accessed and used efficiently. Software engineers use data structures constantly, whether they're building a social media app, an online store, or a data analysis tool. Choosing the right data structure can make your code faster, more organized, and easier to maintain. Have you ever wondered how a website organizes all your profile data, like your name, your email, date of birth, preferences? Well, that's done through data structures, often including lists and dictionaries, or even stuff like classes and objects, which is a little bit more advanced. What is a list? A list is an ordered collection of items, which can be numbers, strings, or even other lists. You can think of it like a shopping list or a to-do list. Now, how do we create a list? Well, let's finally get into some code. In Python, and like most of other programming languages, when creating a list, you first want to assign it into a variable. For this scenario, we're going to create a list of fruits. So our variable, or our list variable to be specific, will be called fruits. And then we're going to assign it a value. And this value will be a list value. Now to create a list value, it's going to be created and identified by using the square brackets. Opening and closing square brackets will allow you to identify and declare a list in Python. Now, after opening and closing your square brackets, everything within these square brackets will be values within your list. A list can contain no values or as many values as your heart desires. So for this example, let's go ahead and add our very first value, which would be apple. And as you see here, because we are adding a string, even though we are within a list, we have to ensure that we start our string with our quotation marks. So our list can hold all different types of values, whether they are integers, whether they are strings, floats, booleans. The convention of how these values are declared does not change just because they're in a list. So after we add our very first value, I'll decide to add another value, which is the whole point of a list, to be able to congregate multiple different value types or values in general into one data structure. So after apple, I want to add a second one, which is going to be added by adding a comma to identify the separation. And my next value will be banana. So this list of fruits has two different values, which are two strings, apple and banana. Let's add a third, which will be cherry. Here, fruits is a list that contains three items: apple, banana, and cherry. Once again, lists are created using square brackets, and the items are separated by commas. Now, how do we access items within a list? Well, the way that we access the different content within a list is by using indexing. If you recall from previous modules, specifically when using stuff like a for loop, and we iterated through a range, it typically started at index 0. or whenever we access a value in a string, the first value or character inside of a string was typically index 0. Well, lists work the very same. The way that the items are ordered within this data structure, the very first item is at location index 0, followed by index 1 and index 2. So, how do we grab a individual item? Well, just like accessing characters within a string, when you access items within a list, we use bracket notation or index notation. You might hear these words be used interchangeably. So let's say I want to print out fruits. We'll keep it very simple. I'll print out the entire list first. When I run this, I see here that I got apple, banana, and cherry. So let's go ahead and add the indexing. I'm going to open up square brackets after the variable name of fruits, and I will pass in the integer of 0, which now returns just apple for me. If I go ahead and change this to a 1, it returns banana. Now, how do I change items in a list? Well, we're going to take advantage of how we are able to access individual items by using index notation and add onto this to update a specific value. So here, when we first run this print statement, we should be able to receive the word banana back. Now let's go ahead and access that banana keyword by calling the fruits list at index 1. And all we're going to do is reassign it a new value. So we'll say fruits at index 1 is equal to, and instead of banana, let's go with blueberry. And after we reassign it, let's print out fruits again to see what our final outcome looks like. When I run this, I see here that I still get the banana initially at line 2. At line 3, we're accessing the fruits list at index 1 and reassigning it to a new value of blueberry. And at line 4, we print it out again, which is represented here within the output box. Now, how do we add or remove items from a list? Well, there are multiple ways of adding items or removing items. We'll talk about the most basic way of doing it, which is by using the append method. So we can go ahead, we'll print out fruits before we go ahead and add anything in here so we can see the outcome of our list so far, which is apple, banana, and cherry. And after our print statement, we're going to go ahead and add blueberry. Instead of reassigning a new value here or an old value to the new value of blueberry, we're going to add blueberry. So to add it, we're going to go ahead and call our fruits list. And we're going to invoke a new method. This method is fairly unique to order data structures like lists, which is the dot append. So we say fruits dot append, which really we're going to append or add a new value to the back of the list. So by default, append will add a new item to the very end of this list. So we can say append blueberry. Then let's go ahead and print out fruits and see what it gives us. And there you have it. At line 2, we print out fruits without blueberry. After line 3, once we add blueberry, we print out fruits again, and we see blueberry is added successfully at the end of our data structure. Let's say I change my mind. I no longer want blueberry. How do I remove it? Well, very similar to how we added it, we can use another method. So we can call our list fruits, and we'll say dot remove. So instead of appending, we are removing. And we can remove blueberry. Let's go ahead and print this out so we can see the outcome afterwards. And there you have it. We don't have blueberry, we add it, and then we change our mind, so we remove it. Lists are a great way of organizing your data, specifically if you have multiple different values and data types that share some kind of relationship. If you needed a data structure where you can hold them all together and then come back to them later and access them, list is a great way to do all of this. Lists in the workplace, if you ever see these or encounter them, is a great example will be if you're working in a social media app. Think about the apps that you use on a day-to-day basis. Your social media apps, you might be storing a large amount of information, like let's say your friends list. How does a friend list work on your social media? Typically, if you were to look underneath the hood, there's probably some form of a data structure, more than likely either a list or a dictionary that holds this large list of different friends within your friend list. That list can grow or shrink as people connect or disconnect. In an e-commerce website is another example. You might see this in your shopping cart. When you guys are shopping online and you're filling up your cart before you check out, that's another version of a list and how it could be represented within software engineering. Dictionaries. What is a dictionary? A dictionary is a collection of key value pairs. Instead of accessing items by numeric index like in a list, you use a key, often a string, to look up that specific value. You can think of it like a real dictionary where a word, which could be identified as the key in this analogy, maps to a definition, the value. Or another example I like to use is your address. Your home address is where you are located at, and the value that would be where, who is in this house, which would be you. That's how a dictionary kind of works. The key is that memory address of where the values are located at, and the key is what we use to grab those values. But let's see it in some code and look at some syntax. So how do we create a dictionary in Python? Well, in Python, dictionaries are created and identified by using the curly braces. So just like we did with the lists, we're going to create a variable. We can give it a variable name. And for our very first example with dictionaries, we'll use a user profile. So our variable will be called user profile. And it's going to be a dictionary. As I mentioned, these are declared and usually identified by using the curly braces. Now, there is another data structure in Python that also uses curly braces, but the way that you identify these is the very fact that dictionaries use key value pairs while the other data structure doesn't. But we'll leave that for another lecture. As right now, just understand that dictionaries, they are key value pair data structures that are instantiated and created by using curly braces. Now, you could, if you like, create your dictionary here on one line by adding all the key value pairs next to each other. But typically, it can get very confusing when starting to create a dictionary as you add more data. So it's fairly common to separate the curly braces into their individual lines by pressing the enter key while between both of them, which will then create a natural space within your dictionary, which will allow you to add your data types, your key value pairs. So here for our very first key value pair, we're going to give it a name. And I'm going to assign it a value. So key value pairs are separated by using a colon. The item to the left is going to be your key, and the item to the right is going to be your value, which here is going to be Alice. Now, once again, keys can be a variety of different data types. The important thing to take away from what a key should be is a key should be unique. When you try to use duplicate key value pairs, specifically keys, it tends to get overridden. So the biggest rule that you want to take away when creating a key for your key value pairs is that the key should be a unique value. So you shouldn't have or you shouldn't attempt to create multiple different keys of name. There should only be one key of name. The value could be anything you like. It could be a string, data types of all kinds, and even data structures. I could, if I wanted to, create a list here as a value. But we'll keep it simple. The first value here will be Alice, which is just a string. So here, once again, to recap, this is our very first key value pair. Our key is the name. We then give it a colon to identify its pair value of Alice. So this is a key of name and a value of Alice. Now, if I wanted to add other values within here, other key value pairs, just like the list, that's going to be separated by a comma. After the comma, I can just press enter and go into the next line to start my next key value pair. And this one's going to be age, and we'll give it a integer value of 30. So now I got two key value pairs, one key of name, one key of age, and a value of Alice and 30. Lastly, this user profile should have a job as well. So we'll just add job, and their job will be engineer. And there you have it. This is our very first key value pair data structure, or really a dictionary. We have three different keys and values. Key value pair of name and Alice, age and 30, and job and engineer. This is how you create a dictionary. Now, how do we access this dictionary? Well, just like a list, we're going to use bracket notation to access our individual values within our dictionary. But dictionaries, for the longest time, they were known as unordered data structures, meaning they didn't have a specific order when created, like lists. Lists, when you create a list, it starts at index 0, it goes to index 1, and then it increments as it gets bigger. Data structures like dictionaries for the longest time were known as unordered data structures. To a very recent update in Python, they're technically now considered ordered data structures, but it's still common practice to see them being handled as unordered data structures. And the only way that we're going to grab a data structure for now, starting off, is going to be by using the keys. There are other ways of accessing different types of key value pairs in dictionaries, which is what makes dictionaries such a powerful data structures. But the very basic way of accessing these is going to be by the key value pair. So let's start off easy. Let's go ahead and print out the entire user profile. Let's print user profile. When I run this, I get back the entire dictionary, as we see here. Name and Alice, age 30, job, and engineer. That's awesome. Cool. But I don't want the entire dictionary. I only want a specific key value pair. Well, just like this, we're going to use bracket notation, as mentioned earlier. But instead of passing an index, naturally you might think to yourself, should I just pass an index 0, which should return to me a name in Alice? And if I run this, as you see here, I get an error, right? Key error of 0. It doesn't know how to access that item. Well, instead of indexing, we're going to use the key to grab our Alice. As I mentioned before, our key here is almost working like a memory address or some kind of pointer to point us to where our value is located in memory. So, very easily, we can pass in the key in here of name. And when Python runs this, it's going to grab the user profile. It's going to check the brackets like, okay, you want to access something within here. What are you accessing? I see you're trying to grab something with the key of name. Let me return to you the value And it does as such. Here we see the output is the string of Alice. Let's try it out with age. We pass in age and we get 30. Now, how do we add or update key value pairs within a dictionary? Well, one of the items within this dictionary is subject to change more frequently than others, and that is age. Every year, Alice will have a birthday and her age should increase. So we should be able to update this. Well, how do we update it? Well, it's going to be fairly simple, very similar to the lists as well. When you wanted to update a list value, you just easily grab the index and then reassign it a value. And we're going to do the same thing here. We're going to grab user profile. I'm going to grab the key of age and I'm going to assign it a value of 31. And then we can go ahead and print this out as well. We see here we get 30 and 31. We reassigned it using the equal sign, but we can also use something like plus equals. We say plus equals 1, and it does something very similar. It's going to increase it by 1. So we can just assign it a whole new value, or we can just do a plus equals of 1 and increase its value. So that updates an existing key value pair. But how do we create a new one? Well, it's as simple as calling the dictionary itself, opening square brackets, and passing in this key value pair that you want to create. So you call the dictionary name, and then you pass in the new key that you want to add, which is going to be email. The email should be something like Alice at, we'll say, example.com. And then we can print out our user profile. And we see here that we now have an email key value pair at the very back of our dictionary. So you don't have to use any fancy built-in methods like append or anything crazy like that to add. You just need to set it to a key and a value. So you call the dictionary, pass in the key that you want to add, and give it its new value. Now, how do we remove this email? Let's say we no longer want this email assigned to this user. So we can go ahead and use a built-in method called del for delete. So the keyword starts with the delete keyword. We're going to pass in the dictionary that we want to delete from and its key. And let's say maybe instead of deleting the email, let's delete the job. Let's say we got laid off or we decided to find a much better opportunity for us somewhere else. So we're going to delete this job key value pair. And I want to print out user profile at the very end of this to see how this looks like. And I run this and job is no longer present. A dictionary is often used to store more complex label-based data. For instance, in a user account system, you might have one dictionary per user with fields like username, email, join date, maybe like login status. In data analysis, dictionaries let you quickly map IDs to detailed information, like a dictionary mapping product IDs to prices. Lists versus dictionaries. When to use a list. When having to compare between a list or a dictionary and when should you use one over the other, there's a couple things that you should take into account. The times that you should use a list should be if you need to create an ordered collection of items. Like you need to know what is the original order of your values. So, for example, steps in the process like maybe a a recipe, or a queue of tasks to do next. Um, Lists, because they are naturally ordered data structures by nature, then it's common to have them in place in the order of how they are created. So a good time to have a list is if you know there's a set order they should be. And then a time that you might want to think about using a dictionary would be if you need to use something like maybe creating map labels, um, which are keys to different values, right? If you had something like user attributes, and each user attribute had properties, a great example would be, think of a game, a role playing game, that you want to create the stats of a character. You want to have a character stats like their strength. It's a value of 10. Agility could be a value of 15. Vitality, value of 20, and so on and so forth. So whenever you have some form of data type that requires a name, or some form of label, and then given a value, that's when dictionaries shine. Another type where dictionaries might feel like a much better use would be if you need to access information a little bit more rapidly, which we'll talk a little bit more as we go through our modules. You'll come to find out that accessing items in dictionaries is a lot faster computation wise in your computer than it is for a list. A list, because it's an ordered data structure, typically by nature, you have to access it from start to end, where a dictionary, we have the keys to map our way directly to the value if it exists. But ultimately, in real projects, you often see lists of dictionaries, or even dictionaries that contain lists. So you might end up mixing and matching these data structures very often. And this can help you model complex data in a clean and organized way. What's coming next? Up next, we'll dive into some practical exercises. First, you'll get hands-on practice working with lists, sorting, adding, removing, and iterating through them. Then, we'll do the same with dictionaries, exploring real-world examples like storing user profiles or menu items in a restaurant app. Keep in mind, the best way to master these data structures is to use them. Experiment, break things, and then fix them, as well as repeating this entire process all over again. Recap. Lists and dictionaries are powerful, flexible tools for organizing data in Python. You'll see them practically in every Python codebase, from hobby projects to major industry applications. Get ready for our hands-on videos, where we'll show you exactly how to use lists, dictionaries in your own projects. Until then, try experimenting with a few small examples. Happy coding!